Welcome to Class 10 Insight. In today's class, we shall be discussing about few of the common mistakes which you usually do in your exams in mathematics. So here are the few hints you will have to keep in mind so that you will not be repeating the same mistake. So this will definitely help you to avoid mistakes and score good marks in your exams. So let us start with the topic. We shall start with applications of trigonometry. So many of the students will be having confusions with angle of depression and angle of elevation. Suppose this is the kind of the question. I have just taken a part of the question. The angle of depression of the top and the bottom of 50-meter high building as observed from the tower are 30° and 60° respectively. If you sort out this given parameters, then the remaining thing is very easy to solve. That is, you will be finding out the height of the tower. This is the first step where you people get confused and you will be confused to mark 30° and 60°. So first let us see how to mark this 30° and 60° when it is given as angle of depression. Here are few of the daily life examples. So here is the observer and his sight of and his line of sight where the vision is going to be observed, that is the normal ray 90°. That I take it as horizontal. That from that horizontal line, I will be judging which is the angle of elevation and which is the angle of depression. As you all know, when we look above that horizontal line, that is angle of elevation. When I am seeing below that line, it is angle of depression. It is as simple as that. So here the man is observing an aeroplane from the ground level. So we take this, his vision above this horizontal, I take this as angle of elevation. That is the normal ray. Then below that horizontal line, I take it as angle of depression. Same way here also, a boy is going to observe the top of the building here. It could be first or second floor, somewhere here above. From his sight of vision, I take a normal ray, that is the horizontal line. From that, above that vision, I take it as angle of elevation. And when he is observing the ball below, so he will have to look below down this horizontal line. Then I take this angle as angle of depression. This angle, when he is observing below, the angle that is made with respect to this horizontal line, I call it as angle of depression. That is very important. With respect to this horizontal line, only the angle formed will be taken as either angle of elevation or angle of depression. If he is looking above, it is angle of elevation. If he is looking below, it is angle of depression. One more example. So before that, let us see the definition. The angle of elevation is the angle between the horizontal line. The angle of elevation is the angle between the horizontal line from the observer and the line of sight to an object that is above the horizontal line. So if the object is above the horizontal line and the angle made by the viewer above the horizontal line, then we call it as angle of elevation. Angle of depression is the angle between the horizontal line from the observer and the line of sight to the object that is below the horizontal line. That angle made with the horizontal line, we call it as angle of depression. Now, a boy who wants to see the girl who is standing below this 50 feet tall building, we have a straight line that is the horizontal line. That is, we also call it as the line of sight. So when he is looking below, the angle that is going, when he is looking at the girl, the angle made by that view, with this horizontal line, we call it as angle of depression. Now, I am going to draw a line from the foot of the building to the foot of the girl and observe these two lines. They are parallel. And if we observe, we can make out it is Z-shaped angles, nothing but alternate angles. Hence, they are equal. This is one of the logic you will have to remember. So this is actually a basic point which everyone will remember. The only thing you make mistake is you tend to forget to mark this angle of depression from this horizontal line. If that is done, then you will easily mark the alternate angles and you can proceed with your calculation taking this as equal, and you will be able to find the height. So, as per this given question, you will draw this diagram. Now, on observing the angle of depression of the top and bottom of 50-meter high building. So, this is the building we have. So, this is the building we have. It is 50-meter high. So, since we know it is the angle of depression from the top of the tower, so this is the tower which is TR, which is definitely by common sense which is taller than the building. From here is the vision happening, and this is the horizontal line, that is the line of sight where he is going to be observing. The observer needs to observe from this horizontal line when he is looking down to the top of the building. So, to the top and the bottom of the building, and they have given the angle respectively. So, 30° will be to the top of the building and 60° will be to the bottom of the building. So, when we are going to observe from here, the angle made while looking down, that is angle of depression, to the top of the building with respect to this horizontal line is 30°. Hope it is clear. The observer is observing from here. This is his line of sight, nothing but the horizontal line. When he is observing from here, when he is looking down, even though it is the top of the building, but from the tower, he has to look in below. He has to look below. So, it will be angle of depression. And how will we know the angle? It will be measured with the horizontal line. So, that is 30°. Now, when I am going to draw a parallel line to this horizontal line, these two lines are parallel. When these two lines are parallel, then we can easily make out we have Z-shaped angles here. So, this angle at T here, F will be 30° and the angle here at B will be 30°. So, we came to know that the angle of depression, how it should be marked and how the alternate angles will be marked, and we also came to know that the angle of depression, how we mark from the horizontal line. When I am looking at the top of the building, I will be drawing the parallel line from the top of the building itself so that these two angles will be equal. In the same way, now coming to the one more angle of depression, that is when it is going to be observed from the top of the tower, to the bottom of the building. So, if this is the whole building, G, this will be the bottom of the building. Even though now the observer here is at the tower, top of the tower, when he wants to look at the bottom of the building, definitely yes, he has to look down. So, when he is looking down, it is angle of depression. But how will this angle of depression be measured? It will be measured from the horizontal line. So, with the horizontal line to the view, to the bottom of the building. So, I will be taking this angle from the horizontal line to his line of, to that horizontal line and to the line where he is going to view to the bottom of the building. That is very important. Many of the children mark only this angle as 60, which leads to lot of confusions and definitely will not be getting the right answer. So, you have to take the angle from the horizontal line to the observer's view. So, that will be 60°. Now, since we are observing to the bottom of the building, we will be drawing the line parallel to the horizontal line from the bottom of the building. So, now this horizontal line is this parallel line. Now, this line is parallel to this line, that is line GR. Now, getting the angle, if you observe, we have Z-shaped angle. Here it is 60° and here it is 60°. Again, we got alternate angles, which will make your further calculation very easy. So, which are the 2 points we have to keep in mind? Whenever you are going to mark the angle of depression or angle of elevation, you will be taking that angle with respect to the horizontal line, that is from where the observer is going to view. It could be below or it could be above. Coming to the most common mistake done by many of the students. For example, if this is the problem given, you are supposed to find the total volume of the solid. You can see there is a combination of two geometrical figures. One is a cylinder and another one is a hemisphere. So we have a cylinder and two hemispheres. In order to find the total volume of the solid, we have to find the volume of the cylinder plus volume of two hemispheres. So if you know the formula, it is very easy, but at the same time, the method of simplification is also equally important. In the next video, I will be showing you the detailed solution of the problem. Since we are focusing only on the common errors done by the students, I'll just focus on what are the errors you have to avoid. So, volume of the solid is equal to volume of cylinder plus volume of two hemispheres. What is the formula for volume of a cylinder? It is pi r square h plus, write this 2 as it is since we have two hemispheres. So what is the formula to find the volume of hemisphere? It is 2 by 3 pi r cube. You can observe we have pi r here also and pi r here also. Many students, what they do, they find out the value of pi r square h, they write it here, then again find the value of pi r cube, multiply it by 2 by 3, then multiply it with 2, which is tedious, time consuming, and chances of making mistakes is also more. So in order to avoid mistakes and to save your time in exam, what we have to do is take pi r common. We have pi in both the cases. Here we have r square and here we have r cube. So we can take r square as common. So what is remaining here in the first term? It is h plus 2 2s are 4 by 3. Pi is already taken out, r square also taken out, remaining is only 1r. So remaining is h plus 4 by 3 r. If you are going to solve in this way, it will save your time and also reduce mistakes. We should be very careful while simplifying. As the name says, simplifying is what? We are going to simplify our calculation. We should not complicate it. So when you take these values separately, pi r square h value separately, then pi r cube value separately, then multiply, instead of simplifying, you are complicating your calculation. So in order to simplify, what is the easiest method we will be doing is to take this pi r square common. And while solving these type of problems, you can observe here in the question, they have given you the value of pi, that is equal to 22 by 7. You will have to take the value of 22 by 7, even though if it is not mentioned in the question. You know that pi value is equal to, when it is reduced to the decimal form, if it is mentioned, usually in the questions it will be mentioned as use pi is equal to 22 by 7. If it is not mentioned, please avoid taking 3.14. 22 by 7 will give you the most appropriate answer, whereas 3.14 doesn't. What is the reason for that? Because we know that the value of pi is non-terminating and it is also non-repeating. It is a non-terminating and a non-repeating decimal value. The series goes on. That is pi is equal to 3.141592653589. It goes on. And when we are calculating, we will just take two places of the decimal value. And when you get the final answer, there will be a variation in the answer because we have not taken the complete value of pi. Hence, it is better to take pi as 22 by 7. Only if at all it is mentioned in the question as use pi is equal to 3.14, then you can take this value. In the same chapter, when we are finding TSA or when we are finding volume or CSA, whatever it could be, we will be coming across the parameters like height, its diameter, radius, various things. Suppose, let us take an example. Height would be given in centimeter and the diameter would be given in meter. Many of us overlook the units. Whatever is the numerical value given, we directly substitute them in the formula and we get a wrong answer. Both the parameters which are being used in the formula should be of the same unit. You either convert this height to meter or else convert the diameter given to centimeter. Then only the substitution work has to be done. Later on, simplification. Then, coming to the next concept, when we are finding the LCM or when we are following prime factorization, let us imagine we have to find out for the number 212. So, since it is ending with 2, we know that everyone knows we will start with the even number 2. 2 ones are 2. Now, is 1 divisible by 2? No. Immediately, we have to take 0 because 1 is not divisible by 2. It is lesser than 2. Then we will take two numbers together. Then we will have to divide it by 6. So, 2 6 are 12. Then goes on 2 5s are 10, 2 3s are 6. This is how the process continues. Many of the students, instead of doing in this way, what they do, they take 2 ones are 2. 1 is not possible. Without taking 0, they take 2 digits and they write it as 2 6 are 12. Hence, the answer is definitely wrong. You are supposed to get 106, but you are getting it as 16. Let me take one more example. Suppose the question is 510. You are supposed to find the factors or the LCM. So, what happens? We will take it as 5 since it is ending with 0. 5 ones are 5. We will take it as 5 ones are 5. 1 is not possible. So, take 0, then take 2 digits together. That is 5 2s are 10. Many students, what do they do? 5 ones are 5. 1 is not possible. Blindly take 2 digits without entering 0. Then write it as 2. 12 is a wrong answer. You are supposed to get 1 not 2. So, this is the major mistake many of you do. So, please avoid silly mistake. Coming to the next topic, suppose there is a basic division. Let us imagine we will be dividing 3.7 by 4. 3.7 divided by 4. Divide 3.7 with 4. Is it possible to divide 3 by 4? No, it is lesser than the divisor. So, take 0. 4 zeros are 0. 3 minus 0 is 3. Take the decimal point to the quotient. Bring down 7. So, we have 37. 4 9s are 36. It is the nearest multiple. 37 minus 36 is 1. Now, we take 0 here. What is the reason for taking 0 here? Many of you think that just because we have a decimal point in the quotient, we are taking 0. No, it is the wrong reason. 3.7 is nothing but 7 followed by zeros. 3.7, 3.70, both are same. So, the 0 which was here has been brought down. So, 4 2s are 8. On subtracting, we get it as 2. Then again take 0. 4 5s are 20. That is the answer. So, this is the common mistake many of you do. As a result, what you do, you also take a 0 in quotient because you don't know that 3.7, 3.70 or 3.7 followed by n number of zeros is of same value. Coming to the next topic, that is with the linear equation. Suppose we have two linear equations of the form a1x plus b1y plus c1 is equal to 0, a1x plus b2y plus c2 equals 0. In the first condition, if a1 by a2 is not equal to b1 by b2, you very well know that we have one solution. But how will you know that? Graphically, when we are going to plot this equation, we get the solution where they intersect at a point. So this is the nature of the graph for the linear equations where a1 by a2 is not equal to b1 by b2. In the second case, where a1 by a2 is equal to b1 by b2, that is not equal to c1 by c2, there will be no solution. How is the nature of the graph? We get two parallel lines. It is very clear that there are no solutions for these kind of graphs. Coming to the third case, where a1 by a2 is equal to b1 by b2, that is equal to c1 by c2. Here we have infinite number of solutions. What is the nature of the graph? When we plot it on the graph, we get a single line where the solutions are coincident, that is, they are overlapping. Hence, we get the infinite solutions. If you know the nature of the graphs, how we are going to get the solutions? So, we have a compulsory question on graphs also. So, when you are going to solve, if you are going to cross check whether a1 by a2 is equal to b1 by b2 or whether it is not equal to b1 by b2, if it is equal, whether it is equal to c1 by c2 or not equal to c1 by c2, then you can cross check with the nature of the graph also. So you will be knowing, before plotting the graph, you will have an idea about how will the graph come. So you can cross check your answer in this way, or else you can cross check before plotting the graph. Only if you're going to check that, you will have an idea how the graph is going to come. So this method, this trick will help you to avoid errors when plotting the graph, as well as this will help you in solving MCQs. Next is the most important topic when you're finding area and volume. Suppose I have a cylinder where the hemispherical part is scooped out. If the hemispherical part is scooped out, then if this was the cylinder, if the hemispherical part is scooped out, yes, definitely this part of volume is removed. This part of volume will not be applicable. Only this is the area where we can fill it. Hence, there will be a change in its volume. But if you observe here, in a cylinder, suppose this is the cylinder, when its hemispherical area is going to be scooped out, will the area change? Only the extras what we have will be removed. The area will not change. It is the volume that changes. So this is a very important point. Whenever you come across the word scooped out, you get confused and you apply the same logic to both area and volume. The area will not change when you are going to scoop out a hemispherical part from the cylinder. One such problem will be solved in the next video. You remember this hint, it will help you to avoid many mistakes. Most of you get confused in this. Hope you will not repeat this mistake again in your final. Hope you understood these basic concepts and try to avoid these errors in exam so that you can get good marks. Hope this video was useful.